In question 6, the problem statement says, a circular park of radius 20 meters is situated in a colony. 3 boys, Ankur, Syed and David, are sitting at equal distance on its boundary, each having a toy telephone in his hands to talk to each other. Find the length of the string of each phone. So here's a figure that I've drawn for this problem. The circle here represents the circular park, and this park has a radius of 20 meters. The 3 boys, their positions are this point A for Ankur, S this point for Syed, and D for David. So these are the 3 boys, and they are sitting at equal distances from each other on the boundary, which means that the arc lengths between 2 boys are the same. Any pair of boys are the same. So the arc length DA, the arc length AS, and the arc length of SD, these will be the same, which means that the corresponding chords will also have the same lengths. So DA, chord AS, and chord SD will also have the same or identical lengths. So DAS forms an equilateral triangle. Now what we have to find is the length of the string of each phone, and this string is basically represented by the segment joining 2 boys, 2 positions. So for example, the length of the string between Ankur and Syed will be the length of this chord AS. So we have to find the length of the string of each phone. The 3 lengths will be equal because, as we discussed, triangle DAS is an equilateral triangle. Okay, now here's how you can solve this very interesting problem. Take the center O and join it to all the 3 points A, S and D. So we have OA, we have OS, and we have OD. All these 3 segments are radii of the circle, so they will have the length 20 meter each. Each of these 3 will be 20 meters. Now I want you to focus on one of the 3 smaller triangles. So let's take the triangle OAS. Okay, so OAS. Let's think about this triangle. In particular, I want you to think about the area of this triangle. How can we calculate the area of this triangle? Well, we can drop a perpendicular from O to the base AS like this. So this is the perpendicular. Let's take this foot of the perpendicular to be M. And now we can write the area of triangle OAS as half into base AS into height OM. So we'll come to the area part. Let's assume that the length of AM is X meters. Okay, and our objective is basically to find X, because once we have the length of AM, we can just double it and we can get the length of AS, because AS is double of AM. So this is what we're going to do. We are going to find the value of X using some area calculations. So the length of OM can be written using the Pythagoras theorem. So OM will be equal to root of 20 square minus x square using the Pythagoras theorem. So OM will be root of 20 square is 400. So 400 minus x square, these many meters. So this is the length of OM. Now we can write the area of triangle OAS, because we have an expression for AS as well as OM. So area of triangle OAS will be half into the base AS into the height OM. So let's plug in the expressions in terms of X. So half into AS will be, AS is twice of AM, so AS will be 2x into OM will be 400 minus x square. So these many meters square. So this 2 and 2 cancels out. So we have x times root of 400 minus x square meter square. So this is the area of triangle OAS. This triangle I have highlighted. So what do you think will be the area of the whole equilateral triangle DAS? Well, DAS is 3 of these triangles put together: OAS, OSD and ODA. So the area of triangle DAS, the full equilateral triangle, will be 3 times this expression that we obtained. So we can write it as 3x times root of 400 minus x square, these many meters square. So this is the area of the equilateral triangle. Now the interesting thing is we can also write this same area in a different way. We know that the area of an equilateral triangle is root 3 by 4 into side square. This is the expression to calculate the area of any equilateral triangle. So for the same triangle DAS, the equilateral triangle, we can write its area in a different way. We know that its side length is 2x meters because AM is x meters, so AS is 2x meters. So the side length of the equilateral triangle is 2x meters. So its area can also be written as root 3 by 4 into side square, so 2x square meter square. So how much is this? We have root 3 by 4 into 4x square meter square. So the 4's cancel out and we get root 3 x square meter square. Now here comes the key idea behind the question, behind the solution. We have written the area of the same triangle DAS in 2 different ways, like this, 3x into root of 400 minus x square, and like this, root 3 x square meter square. So what we are going to do is we are going to equate these 2 expressions, and this will give us the value of x. So let's write this here. So 3x times root of 400 minus x square, this is the first expression for the area, should be equal to root 3 x square, the second expression for the area. And by solving this equation we can find the value of x. So let's solve this equation now. Okay, so we have an x on this side and we have an x square on this side. So we can cut one x and we'll be left with x. And we have this 3 here and we have this root 3 here. So we can actually divide this 3 by this root 3 and we'll be left with root 3 on the left side. So if I have to rewrite this equation, I can write this as root 3 into root of 400 minus x square, and on the right side I will simply have x. Now I can square both sides of this equation. So if I do that, I will get 3, the square of root 3, into the square of this term, root of 400 minus x square, will simply be 400 minus x square, and this is equal to, on the right side we will get x square. Now this seems to be getting easier and easier. If we multiply the product on the left, if we expand the product on the left, we will get 1200 minus 3x square, and on the right side we get x square. Alright, now finally this it has become really easy to solve. So this minus 3x square we transpose to the right side, that becomes 4x square. Let's write it on the left side, 4x square, and then we'll be left with 1200 on the right side, and this means that x square is 1200 by 4. So 1200 by 4 is 300. So x square is 300, and this means that x is root of 300. Now 300 I can write as 100 into 3, and root of 100 is 10. So this can be written as 10 root 3. Awesome, we have found the value of x, which gives us the length of AM, which means that the length of AS is now simply double this value. So AS is 2x meters. So 2 times x is 10 root 3 times 2, or 20 root 3 meters. And AS is the length of the telephone string between Ankur and Syed, and this is also the length of the other 2 telephone strings, because the triangle is equilateral. So the answer to this question is that the length of each string is 20 root 3 meters, and this completes question 6. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.